and bandwidth of RC coupled CE amplifier. Here you can observe that the frequency response of an amplifier, why we need it? Because as you know very well, the single stage RC coupled C amplifier can be used in audio frequency amplifier where we need to have the frequency range in the range of 20 hertz to 20 kilohertz. Okay, with the same voltage gain, that means the voltage gain should be constant ideally, but practically this does not happen. You get the frequency or the voltage gain low at low frequency as well as at high frequency region. So for this purpose, to use amplifier in various audio applications, we have to check its quality or its performance parameter. For that purpose, we have to plot the frequency response of an amplifier. Okay. So this frequency response of an amplifier is basically consist of three regions. First portion is of mid frequency region that you can observe here. Next portion is nothing but this portion is of low frequency region, and this portion is of high frequency region. So low frequency region, at low frequency region, what you observe here, that in uh, in three different region, the very first region, the low frequency region, the gain or the output voltage decreases due to increased reactance of coupling and bypass capacitor. So this effect, instead of getting constant voltage gain, here you are getting the decreased in the voltage gain. This is because of only the increase in the coupling and increased reactance of coupling and bypass capacitor. While in case of mid frequency region, the gain is almost remains constant in case of mid frequency region, and in case of high frequency region, the output voltage and or the gain will decrease due to internal stray capacitance. For this portion, the decrease in the gain causes due to internal capacitance and the stray capacitance. Now main part is at mid frequency region. To calculate the bandwidth of an amplifier, we have to consider the frequency value, the specific frequency value, that is, we have to consider the low power frequencies. Okay, so here F1 and F2 are the low power frequencies. Hmm, denoted by F1 or F2, or you can say the FL or FH, where FL is the low frequency and FH is the high frequency. Okay, here you can observe the three regions that I already explained you about: low frequency region, mid frequency and high frequency. Now, the next part is about the what is this F1 and F2. F1 and F2 are also called as half power frequency or 3 dB reduced frequency, or you can say the cutoff frequencies. Now, what is this F1, the lower cutoff frequency? It is the frequency of the input signal at which amplifier gain or output voltage reduced to 70.7% of their mid frequency range. So similarly, FH is also the upper cutoff frequency, where again gain reduces to 70.7% of their mid frequency range. Why this gain reduces? Because of only the coupling capacitors, bypass capacitors and the internal capacitors of transistors. So you can say that the factors affecting to the bandwidth of RC coupled amplifier are coupling capacitors C1 and C2, bypass capacitor CE, internal capacitance of BJT. So here we can calculate the bandwidth. Bandwidth can be calculated by reducing the gain by the value 3 dB, or you can say the 0.707 of AV mid. This 0.707 of AV mid, and the difference between these frequencies, that is upper cutoff frequency and lower cutoff frequency, that is F2 minus F1, is called as bandwidth, where F2 is always higher than F1 and it is typically in the range of kilohertz. So this was all about the frequency response of RC coupled CE amplifier. Clear?